Now we will learn about the topics of sensation and perception. First, let's define the terms. Sensation is defined as the detection of physical energy from the environment in the form of neural signals through the senses. So, our five senses are vision, hearing, our sense of touch, our sense of smell, and our sense of taste. So, throughout the day, we receive information from the environment through these senses. So, for example, light waves enter our eyes, sound waves enter our ears, molecules enter our nose, and we receive this information. And so, sensation is a physical process. Now, perception is the interpretation of this sensory information, and this is a psychological process. So, for example, the sensation of our vision would be the light waves entering our eyes, and then this information travels via the optic nerve to the visual cortex, and then that's where perception takes place, the processing of this sensory information. So, an easy way to think about the differences between these two terms is that sensation is purely physical and perception is psychological. And let's go on and then hopefully it will make more sense. Okay, maybe you remember this viral sensation. What color is this dress? So the internet went crazy over this dress, and there were many passionate arguments amongst friends and family members about what color is this dress. So it was so fascinating because many people adamantly claimed, that it was gold and white, but some people saw black and white or black and blue. And so, how can this be? We're all looking at the same picture of the dress, but how can people be seeing something different? Well, as we explore this topic, you'll see that the answer lies in perception. A lot can happen in terms of perception to influence what a person sees. So that's what's going on. All right, now let's look at this example. Take a moment and listen to this.
Do you hear Yanny
Yuri, Yuri,
or Laurel?
Yuri, Yuri.
A recent Twitter poll found that 47% of people hear Yanny, while 53% hear Laurel. Clearly, this has created an internet argument that is dividing the nation. So, what is the science behind the madness? One of the first aspects is priming. If you were to play this clip without providing the option of Yanny or Laurel, you may have heard neither of these words, but by reading them, you're primed to hear one or the other. Secondly, when you speak, you are producing sound waves, which propagate through the air. This is a visual depiction of the sound waves of the original Yanny/Laurel recording, created by Brad Story, a professor of speech, language, and hearing. Here is the depiction of him saying Laurel. You can see that the acoustic features are very similar. Here is a depiction of him saying Yanny. The acoustic features are also similar. So the words Yanny and Laurel audibly are more similar than you might think. Whether you're listening on a laptop, phone, or headphones will influence what you hear based on sound quality. But what if you are listening through the same device, but you hear different things with someone next to you? It might have to do with the age of your ears. The sounds in Yanny play at a higher frequency than the sounds in Laurel. As we age, our ears are less able to hear higher frequencies. So if you are hearing Yanny, you might have younger ears. Luckily, with the help of the internet, we can hear both. Brilliant Twitter user at XXV posted audio of the pitch brought both down and up. When you listen to it brought down 30%, you will hear Yanny.
Yuri, Yuri.
But when you listen to it with the pitch brought up 30%, you will likely hear Laurel.
Laurel, Laurel.
Your brain has so much stimulus at all times that it uses existing information and precise neurological pathways to focus its attention. This is why at a loud party you can listen to your friend beside you, but pop your attention into another convo if need be. Similarly, your brain is unconsciously choosing which frequencies in the recording to pay attention to. So, what is the final answer? If you heard Laurel, you are correct. The original recording is saying Laurel, but with higher frequencies overlaid, creating ambiguity. Love learning about amazing and interesting things in the world. We actually just
All right. So, another interesting example of how, even though we're being exposed to the exact same sensation, the exact same sound waves, people perceive things differently. And that's because there's a lot of other factors involved that can influence what a person perceives. Now, to talk about this a little bit more, we have two theories of perception. Now, one thing to keep in mind is that the brain naturally looks for logic and order. And the two theories of perception are called bottom-up processing and top-down processing. So bottom-up processing means that we perceive starting at the basic level of sensory processing, and then we work up to higher levels of processing. So one example is reading. To read, first we must perceive the individual letters. That's the most basic level of processing. Then from there, we have to know that each letter represents a particular sound, and then we put the letters together to form words, and then from there we perceive sentences and then paragraphs and so on. So we go from the bottom up. So that's called bottom up processing. Now, top-down processing, that means that we perceive by drawing on our experiences, expectations, prior knowledge about the world, the context, culture, and unconscious inferences to fill in any missing gaps and accurately interpret sensory information. So top-down processing is fairly complicated. Now, oops, let me go back, sorry. Examples: putting a puzzle together while looking at the picture of a puzzle. That would be an example of top-down processing. You start with the picture, and then from there, you put the puzzle together. Or another example is if you cover the moon with the tip of your finger. Now, if you do this, it looks like the moon is the same size as the tip of your finger. But of course, due to top-down processing, you know that that is not the case, because as a child, you learned about space and you learned that the moon is very large, and that it's definitely not the same size as the tip of your finger. So that's an example of using your prior knowledge about the world to help you perceive something correctly. Or another really common example is when you read and there is a typo, most of the time your brain won't even notice it. So for example, you're reading something and maybe there is a word left out, like and or the, and that typo has been made. Well, you will probably not even notice it. Your brain will automatically fill in the missing word. Or if someone has made a spelling mistake and they left out a letter of a word, it's very unlikely that you will even notice it. The brain will automatically fill it in, and that is also due to top-down processing. Now, what do you see when you look at this picture? And feel free to stop the video if you need time to look at it, but go ahead and take a look at this picture, and what do you see? If you see the lines of the flower, that's an example of bottom-up processing. If you see the couple embracing inside the flower, that's top-down processing. So let's go back and take a look at the image again. So sometimes it takes a little while. You have to look at it until you can see two images. Other people, right away, they can see both images. But the most basic level of processing is you can see the flower. Now, top-down processing is if you can see the couple right here, there is a couple embracing, okay? So that's a little bit more complicated. That's drawing on your prior knowledge. So that would be an example of top-down processing. And now the last slide for this section, I would like you to take a look here. What is above the woman's head? What do you see? What would you describe is above the woman's head right here? So just don't think about it too hard. You know, what answer pops into your mind? So with this, it's very interesting because all Westerners, they will say that it's a window. It's a window above the woman's head. But people from other cultures, they do not perceive this as a window. Guess what they'll say? They'll say it's a box. So this is another example of top-down processing, and this is where culture comes into play. Culture influences what we perceive. So of course, in Western culture, we have a lot of windows around. So we interpret this as being a window. But in other cultures, it's very common to carry things on top of your head. So people might carry a bag of rice or a jug of water on top of their head as they come back from the market. And also in other cultures, you know, they might live in more of like a yurt or a hut or something, a circular dwelling with just a hole at the top for the smoke to go out. And they don't really have these rectangular or, you know, square windows. And so culturally, this will influence what you see. So that is another example of top-down processing. Remember, culture comes into play. And that concludes this part of the lecture.